The main objective in theory of moving space is definition of speed and the acceleration of space. This task is complicated by that fact that the speed of light not always depends on the speed of space, and we cannot measure the speed of space by measuring the speed of light. But we can analyze the speed of space depending on scale. We can use any value for it. For example, let's imagine that the gravitational constant determines how much space enters into the object with the mass 1 kg per 1 second. And if multiply the mass of planet Earth by the gravitational constant, we're getting the value of space that enters into the planet Earth per 1 second. If we will divide this volume by the surface area of Earth, we will get the speed of space on the surface of planet. The space enters into the Earth from all sides, and the speed of space is changing while approaching. But if we will imagine that space in the form of cylinder with the base that equals to the surface area of Earth, then the height of this cylinder will be equal to the speed of space on the surface of Earth. In our case, we're getting this value. We can see that it's too small, and the intuition says that it must be around the same order of magnitude as an escape velocity. But now we're not trying to find the exact value. Let's see how it will change on the scale of elementary particles. Let's try to figure out the speed of space nearby the nucleon. And if we know the speed of space on the surface of Earth, how to figure out the speed of space nearby the nucleon with the keeping of proportions. And I have found 3 ways to do it. 2 of them gives the same result and logically correct, and third is not correct, but gives the very interesting result. Let's start with it. Firstly, we need to figure out how much nucleons have the planet Earth. For it, we need to divide the mass of Earth by the mass of 1 nucleon. And now let's calculate the volume of 1 nucleon by using its charge radius. After multiplying by number of nucleons, we will find overall volume of the nucleons. And now let's imagine that all nucleons united in the center of planet, the ball of the nucleons. Then the speed of space on the surface of this ball will be equal to the speed of space nearby the nucleon. Because how many times this ball more than 1 nucleon, so many times the speed of space increases while approaching. So, at the distance of charge radius from the center of the nucleon, we have the speed of space 6.5 times more than speed of light, but it decreases rapidly with increasing of distance. And at the distance around 2 Fermi, it's equal to the speed of light. And now look at this diagram. This is dependence of the strong nuclear force on the distance, which works on the distance from 1.3 to 2.5 Fermi. From the special relativity and from the experiments, we know that the body which moves in the space with high speed gains additional energy, relativistic mass or relativistic impulse, and then with this more energy or mass resists to the following acceleration. And when the velocity of body approaches to the speed of light, this force of resistance infinitely grows. And here we can suggest that the space around the nucleon accelerates to the speed of light and even more. And any particle that enters into this area instantly increases its mass. In this way, the gravity force increases by the orders of magnitude and becomes even more than the electromagnetic force. In other words, the gravity becomes the strong nuclear force. In this case, the interpretation of rest energy sounds very interesting. If the mass determines like a volume of space per unit of time, then the rest energy determines like a volume of space accelerated to the speed of light. That means something like a kinetic energy of space. And here we have one more effect. The close proximity to each other makes tiny deficit of the space because of obstruction. That's how creates the mass defect, which converts to the binding energy. All this sounds wonderful, and even too wonderful. But there's an error in this method. The error of non-compliance of proportions. And all these coincidences is just a coincidences. Let's take a look at next method. Firstly, we need to find the speed of space on the surface of planet per one nucleon. For it, we need to divide the speed of space on the surface of planet by the number of nucleons. And then, dividing the surface area of planet by the surface area of one nucleon, we're getting how much time that speed increases while approaching to the surface of nucleon. And we're getting the next value. The third method. We need to calculate the volume of space that enters into the one nucleon per 1 second. And then, dividing that volume by the surface area of the nucleon, we're getting the same value of speed as in previous method. The absolute magnitude of the speed is very small. But what we can say about the relative magnitude? Let's calculate how many times the volume of space per 1 second more than volume of nucleon. The volume of space more than the volume of the nucleon about 46 million times. But to imagine this in the scale of our planet, let's imagine that the planet Earth is the nucleon, and to the Earth moves and enters the volume of space equal to 36 volumes of the Sun. And volume of the Sun more than volume of the Earth around 1.3 million times. In this case, the speed of space on the surface of Earth will be around 300,000 times more than speed of light. This is a huge number. But if the speed of space on the surface of planet Earth equal, for example, to the first escape velocity, then these values of the speed will be 10,000 times more. However, the speed of space on the scale of the nucleon looks very small, but on the scale of the Earth looks huge. It's so different depending on scale. But what can be common for these situations? And common can be the acceleration. Specifically, the rate of change of acceleration, that called the jerk. And we know that in theory of moving space, the force of gravity depends on the acceleration. And maybe such a quick increasing of acceleration of space provides such a big increasing of the gravity force that the gravity becomes the nuclear force. But is it possible in reality? Is the gravity in the nuclear force is the same force? To answer these questions, we need to understand the nature of inertia, to understand the relationship between the space and the matter, to understand why does appear the force of inertia,